Hi, everyone. Just wanted to take a minute to talk a little bit about how to write exponential functions using a table and then also using a graph. So the first thing that we need to recall when we're dealing with writing exponential functions based on tables and graphs is really we need to remember what the actual structure is, right? So we know that an exponential function is going to be f of x is equal to a times b to the x. And the only restrictions really are that a is not 0, right? Because then if I was just multiplying by 0, it'd be very boring because it would just be 0. B is not going to be 1 because 1 raised to any power is just 1. And b is also not going to be 0. B would also be greater than 0 because otherwise you would kind of end up with this fluctuating pattern if you had a negative. So just keeping those in mind. So what are each part, right? A is going to be our intercept, our y-intercept, and B is going to be our ratio. So A is going to be our intercept, and B is going to be our ratio. So let's just kind of look at this. Well, first off, what do we need to identify? We need to identify our intercept. And what's our intercept? Bam, it's 1. So we know A is just going to be 1. Okay. And what do we have for the ratio? Well, what's happening? Times 2, times 2, times 2. And how could I figure that out? Well, I could just set it up in terms of creating a ratio, right? 2 over 1, 2. 4 over 2, 2. 8 over 4, 2. Right? If you found the rate of change, obviously it's not going to be a constant, but you know that they have a common ratio, right? They're all being multiplied by 2. So that's the difference between this and a linear function, right? With linear function, I'm adding the same number. On these ones, I'm multiplying by the same number. So my b here is going to be 2. Okay? So in this case, my function f of x, or in this case y, is going to be 2 to the x. There we have it, right? Multiplicative rate of change, common ratio, call it whatever you want. I like it actually, I kind of like the wording of rate of change here because as we had talked about, the rate of change is not always going to be a slope. All right, so let's do another one of those. That one was pretty straightforward. Let's do another one. Okay, this one is a little bit tricky. And I say it's tricky because, well, you're dealing with decimals. So again, we have our general structure. F of x is equal to a times b to the x. So what is our a going to be? Well, we get our a from right here. So our a is 0.01. Now, what is happening? I am multiplying 0.01 by something. So let's find a ratio. Whoops, 0.4 divided by 0.1. That is times 4. 0.16 divided by 0.4, that is 4. You can check me on that if you would like, but it is going to be 4. So ultimately, what is our answer? Our answer is going to be 0.01 times 4. Oops. The times. I'll do parentheses just to keep it clear. 4 to the x, right? And that's going to be the basic structure every single time. So if we find another one, right? Very similar. Start at 3, multiply times 4, 3 times 4 to the x, right? 0.2 times, wow, they really like 4. That's the same one. 2, okay, on this one times 3, 0.01 times 3 to the x, okay? So that's going to end up being, all right? So that should be pretty straightforward. If we look at a graph, this one might be a little bit tougher, right? Why might it be a little bit tougher? Because you have to identify points. Luckily, there's a couple points that you can really easily identify, right? You have your intercept of 0.4. So we still have our A being the intercept. It's still 4. And now we need to find our ratios. We need to find a couple different points. So All right, I have 120, 0, 4. All right, so 20 over 4 is going to be equal to 5. Let's just confirm that with a different one. So we have 0.8 and 4. So if you do 4 divided by 0.8, right, what is that going to be? That's the same as 4 over 4 fifths, which is the same as 20 over 4, which is 5. So we have a ratio of 5. All right. So our b is going to, our b is going to equal 5. So my function should be f of x is equal to 4. It's 5 to the x. All right. Let's just confirm that. 4 times 5 to the x. All right, now let's do the next one. We're gonna pretend you didn't see what it just was. But let's look at it. Okay, we're gonna take the same process. So what do we have? We have the point -1, 10, and I have the point 0, 2. So what do I know about that? Well, that means my a is going to be 2. Also, just from looking at this, by the way, what do we know? What can we identify? Well, we can identify the fact that it's going to be a number that is less than 1, right? Because it's decreasing, so you mean you are going to have a fraction. And so we have to find that fraction of that ratio. So what did we say that was? -1, 10, and that would be 2. So let's do the successive terms. 2 over 10, 1 over 5. Let's confirm that. Let's look at the next one. 0.4, 2. 0.4 over 2. Well, 0.4, what is 0.4? 0.4 is 2 fifths. Divided by 2 is the same as 1 fifth. Okay. So our ratio is going to be 1 fifth. So when we are writing the equation, it is ultimately going to be f of x, or I think I called this one g of x, whatever, 2 times 1 fifth to the x. And let's just confirm that. 2 times 1 fifth to the x. And there you have it. All right. So ultimately, I think you're going to be doing pretty well with identifying the equations based on graphs and tables. As long as you remember the general structure, it should kind of follow naturally from what information you have. The only kind of difficult part really comes down to if you don't have the intercept, in which case I would definitely recommend looking at the graph and looking at what the intercept is going to be. Okay? All right. Let me know if you have any questions, and if not, have a great day.